Hello and welcome back to my Arduino and electronics channel. My name is John and this is the third video in a series of tutorials about Arduino and basic electronics. Today we will try to add some external components to our Arduino project and we will learn how to assign names to the Arduino pins. In the previous video, we were successful in blinking the built-in LED on and off. I admit that it is not really exciting to see an LED on the board going on and off, so today we will try to add an external one. For this we will need an LED, a resistor, 2 jumper cables, and a breadboard. Let's see, briefly, what these components are. The LED is a light-emitting diode. As all diodes, it will let the current flow only in one direction. If you reverse the LED, the current will not flow and the LED will not light up. If you look closer you will notice two things. First, one leg is longer than the other, then one side is flat. The short leg on the flat side is called cathode, and it must be connected to the negative side of the circuit, that we call ground. If you look at the Arduino headers, there are a few of them marked GND. These are the ground pins. The long leg of the LED is called anode, and it must be connected to the positive side of the circuit. So, if we were to connect the LED to a battery, this is what we should do. A resistor is a component used to limit the current flow. We will see later why we need to use it. And a breadboard is very useful to quickly wire up prototype circuits, by using jumper wires. We will see how to use them in a minute. If you now connect the LED to one ground pin on the Arduino and to pin 13, which is very easily done like this, with the longer pin on pin 13 and the short one on GND, you should see the LED blink together with the Arduino built-in LED. This is because when we give Arduino the instruction digital write, 13, high, we are actually telling Arduino to connect pin 13 to the positive voltage, so the current can now flow through the LED. When we write digital write, 13, low, we are asking Arduino to connect pin 13 to the ground, so there is no current flowing through the LED. Now what we want to do is to connect the LED to a different pin, let's say pin 12. From what we saw till now, you may imagine that all we need to do is move the LED pin to pin 12, and change all the digital write instructions in the sketch, so we change the state of pin 12, instead of 13. First of all, there is a more practical way to do this. Instead of changing every instance of the instructions where we use pin 13, we should assign a name to the pin we are using. Go to the top of your sketch and add this line, define, LED, 13. Now change the pin mode and digital write instructions. Write LED instead of 13. Upload the sketch again and you will see that it is working exactly as before. This is because we assigned to the word LED the value 13. From now on, every time the sketch will encounter the word LED, it will use the value 13. You can easily see that now if we want to change the pin we are using, we only need to change the definition at the beginning and the new value will be used. So if we change it to 12, all digital write instructions will now act on the state of pin 12. If you upload the sketch now, you will see that there is no activity on the LEDs, because we are now switching on and off pin 12, and there is nothing connected to it. Please resist the temptation to simply move the LED to pin 12, that would be a bad idea. Let's see why. The circuit we built so far only works well because along with the built-in LED there is also a built-in resistor, that limits the current flowing through pin 13. To use a different pin we need to add a resistor. To understand this, we need to first understand the basics of electricity. What do we mean by the words voltage, current, and resistance? Electricity is the movement of electrons. Electrons creates a charge, which we can use to do work. A light bulb, a computer, a phone, and indeed an Arduino board, are all using the movement of the electrons in order to do work. They all operate using the same basic power source, the movement of electrons. The three basic quantities that we use to measure and understand electricity are voltage, current and resistance. Voltage is the difference in charge between 2 points, which is comparable to the amount of water in a tank. Current is the rate at which the charge is flowing, and resistance is a material's tendency to resist the flow of the current, comparable to the size and roughness of a water pipe. So, when we talk about these values, we are really describing the movement of electrons through a circuit in the same way as we would describe the movement of water through a series of pipes. If we compare electricity to water, then the amount of water in a tank represent the charge or voltage. You can see that the more water we have in the tank, the more pressure we will find at the bottom, or the more voltage we will measure. We indicate voltage with the letter V. If we add a pipe to the tank, water will start flowing out. We call this flow current, and we indicate it with the letter I. You can imagine that the actual amount of water coming off the tank depends on the size of the pipe. If we increase the size of the pipe, more water will flow. We call this resistance and we indicate it with the letter R. Now let's go back to our LED. An LED has very little resistance, it is like a big pipe, and it will allow all the charge available to rush through at a great speed, which means a great current. The problem is that the LED can only survive a little amount of current before getting too hot and fail, or even explode. I made this experiment for you, applying 12 volts to an LED, look at what happens. This is obviously not what we want, so we use a resistor in series with the LED. It is like using a very small pipe that will only allow the right amount of current to flow through the LED. But, how can we calculate the exact size of the pipe? How do we determine the value of the resistor? For this we are going to make use of the Ohm law. I promise I will keep math at a minimum, but this one formula is something you will use very often. The Ohm law says that voltage equals the resistance multiplied by the current. V equals R times I. If we reverse the formula we can see that the resistance is equal to the voltage divided by the current. So if we know the voltage and the desired amount of current to flow, we can easily calculate the correct value for the resistor. The units we are using are volt for the voltage, amperes for the current, and ohms for the resistance. We do know that the Arduino pins are at 5 volts when set to high, and if we look at the characteristics of an LED we can see that it should work at about 20 milliamperes. LEDs also have a characteristic called forward voltage which is often shown on the datasheets as VF. This forward voltage is the amount of voltage that is lost in the LED when it operates at a certain reference current, usually defined to be about 20 milliamps. VF depends primarily on the color of the LED. Standard red, orange, yellow and yellow-green LEDs have a VF of about 1.8 volt, while green, blue, white, and UV LEDs have a VF of about 3.3 volts. So, the voltage drop from our red LED will be about 1.8 volts. The V in our formula is found by subtracting the LED forward voltage from the voltage of the power supply. If we subtract 1.8 from 5 we obtain 3.2, so we can use these values in the formula, which becomes resistance equals 3.2 divided by 0.02. If we do the calculations, we will find that our resistor should have a value of 160 ohms. Now, resistors do not come just in any value. The closest standard values are 150 and 180 ohms, so we choose the higher one, which is 180 ohms. This creates another question: how do I know the value of a resistor? As it happens, it is very easy. If you look at a common resistor you will see 4 colored bands. This is the most common way of marking them, although there are other systems. The first 2 colored bands represent a number, the third is a multiplier, and the last is the tolerance. So to identify our 180 ohms resistor, the first band should be brown, the second gray, and the third brown. That means 18 multiplied by 10, which is 180. The last band, the tolerance, will commonly be gold. Now we can check if all this is true. Let's get the breadboard, LED, resistor and jumper wires and build the final circuit. Remember that the pins of a breadboard are connected together in rows like this. Insert the LED, noting where the long pin, the anode, is. Add the resistor. Connect one jumper wire from the LED cathode to GND. And the other from pin 12 to the resistor. Let's have a better look. The LED goes here. Then the resistor here. Connect the cathode to ground. And the anode, through the resistor, to pin 12. Now power up the board, and you will see our external LED working as expected. Feel free to experiment with a different pin. This is all for today. In the next video we will see how to add a button or a switch to turn on and off our LED. I hope you enjoyed this video and I hope to hear your comments and suggestions. If you liked it, you can leave me a like and subscribe to be sure you will not miss the next videos. See you soon on Arduino and Electronics channel.